So good morning. You're probably wondering what this revolution is. I'm still trying to figure it out. Let me give you a little background on myself, the usual spiel before we get going. So I have really two questions that I ask myself when I go to every conference. Who are you and why am I listening to you? So let me answer those questions right off the bat. My name is Ben. We run a research firm called Neuralytix. I'm probably best known for two things. My work as the head of worldwide storage research at IDC, where I also initiated and was the lead analyst for big data research at IDC. During my tenure at IDC, one of my earlier papers that I was the lead author on and was with a co-author of Rick Villas, the esteemed Rick Villas, who unfortunately is not here, we came up with this concept called Storage 3.0. That was about as high as I could count, so we thought that we would stop there. And we had a subtitle of The Next Revolution in Storage Systems, and that's what this revolution concept refers to. And basically, that was a seminal paper back, I think, in the late 2006 or 2007 area on object storage. We started to see what object storage could provide, what object storage is. I don't have a lot of slides, I just want to talk to you. The arguments for object storage was actually quite straightforward. There is nothing on that list that you guys don't recognize. We need to protect our data. We need to make that protection efficient. We need to make sure it's secure. We need to make sure we can archive it and bring it back. But the key element of all data is search and discovery. Okay. It's basically the same arguments we have for the concept of backup. You back up not for the hell of backing up, you back up because you want to get the data back. We keep data because we want to find it again. We want to put it into context. We want to do something with it that makes sense, that creates value, that generates competitive advantage. Insert any business word you like after the fact, all right? At that same time, we were also in the midst of the whole Sarbanes-Oxley and the 20,000 other regulations that made enterprises keep data not because they wanted to, but because they had to. So all of a sudden, you get this cost of protecting this data because somebody else told you to. I don't know about you, all IT people I know are like 5-year-olds. If somebody tells you to do it, you don't wanna. All right? So we had to figure out a way of keeping all this data around in a much more efficient manner. Efficient not only in the capacity that was used, but efficiency in terms of cost. We want to reuse that data because when we reuse that data, that's when we can generate that value. That's why object storage is important, right? The reuse of the data in new contexts. And you'll start to hear words and concepts as I talk through here in which the concepts of big data come into play as well. And you'll see a lot of parallels between big data and object storage. Okay? Security becomes an important thing because if we are keeping all this data around, we need immutability, we need chain of custody, insert any sort of governmental compliance set of words you want, those concepts apply. All right? Now, how do we do that? Because if all we're dealing with is block storage, ones and zeros, it's frankly impossible, right? We went to file storage because humans don't like to think in binary terms for billions of objects. All right? So what did we do? We collected these ones and zeros into some sort of package and we put a name against it. That's what we call a file name. All right? And for a long time, 20 years or so, that worked pretty well. So long as you knew the file name, you could search for it. That doesn't mean you knew what was inside the file. We'll get to that in a second. But the challenge with file systems is that the attributes that they had, or the descriptors that they had, were not particularly useful beyond the basic file name and maybe the file type. So if you had a file that was called letter.doc, You got a pretty good chance it's a Microsoft Word document at this point in time, or let's make a docx, then it's a more recent Microsoft Word document, and we now know that it is a letter. We have no idea to whom this letter is addressed. We have no idea who wrote the letter. We have no idea about what this letter is about. We just know that we have a letter. So that's okay. Now we can identify some of these challenges. But what happens when you generate the second letter? Some ingenious person came up with the concept of putting the number 2 behind it. Now we have letter.docx and letter2.docx. Again, I want to identify the fact that we don't know what these letters are about, to whom they're addressed, from whom they are written. And the object layer is being able to distinguish between these things. How can we distinguish it? We can go to our final attributes, we can look at who the user is, who the group is, that helps. We can figure out when it was modified and when it was created, maybe. But really, that's about as far as we can go. Oh, we can make it read-only too, because we don't want to write the letter, we just want to read the letter because we want to read somebody else's stuff. But it isn't helpful to us. And in this day and age, when we're now talking about not gigabytes of data or megabytes of data, but petabytes and exabytes of letter, it's like when you have your digital cameras. You know that by the time you've taken your 12,000th picture, it's image underscore 12,000.jpg, JPG, yeah. You don't know what it's about. And that's where we need to add some more flavor to it. And that's where object storage really comes into play. We need to start describing these data objects. The paper in which we wrote, I don't have the authority or the copyright anymore to distribute it. It's also off the IDC.com website because it's old. I actually found this diagram on the public website so that I can use it, but the source is still back to IDC. It's a little rough because, again, it's not the original document. But what I wanted to do was show what storage or object storage is all about. Okay, and the object storage is about the ability to describe data in a way that makes sense. So those are letters that I referred to. Yes, we have a descriptor called letter. We have a data type called docx. Now we can start putting user-definable attributes such as writer equals Ben, recipient equals someone else, subject equals complaint, something to that effect. That stuff makes sense to us, right? Now I can go search for it, or better still, I can put a policy against it, where I can say the policy is where writer equals Ben, delete. Right? Let's use something more useful than deleting my stuff. Let's put an economic parameter around it, where writer equals Ben, put on the cheapest storage we can find. Where sender equals CEO, put it on a flash drive for him to take home and put it on the fastest medium you can have. These things make sense. I can do something with this. So now we can put user attributes such as regulatory compliance information, regulatory compliance information equals true. We can find all that stuff, I don't care how it's related, and now I can put it in a special area, wherever you want to do it. Cheap storage, important storage, write-only storage. Now we can start adding user attributes that says, if you open this, I want to record when, who, and possibly why. All right? Now we have chain of custody. Now we have compliance. All of a sudden, these ones and zeros that started out as a letter.docx now has some relevance and context. It doesn't always have to sit in the drive C:users Ben/documents, because frankly it doesn't matter where it sits so long as I have some reference to that specific object. Right? Now all of a sudden I have much more information about the data that we have, or the data objects that we have. Does that make sense so far? Nod? unless that's falling asleep, I'm not quite sure. Okay, let me explain sort of this picture. It's a really beautiful picture. I thought so anyway, so that's what you have to live with. At the center of this, I'm going to come down here for a second. Right here. So in the center, you're going to see media. And it's not just disk. It can be tape. It can be, frankly, any form of long-term storage you like, punch cards, whatever. Okay. This layer holds the ones and zeros. Okay, and that's what we're talking about. The next layer is the internet connect layer, which is essentially the networking that holds the ones and zeros to something more intelligent. The middle layer is the shared file services layer. We called it file services back then. Here is where we start to put descriptors or user-definable metadata against it. Right? So this is the layer in which we start to describe what's going on. And then the yellow layer, which is the thickest layer, is where we start to do something interesting with it, such as putting economic attributes, individual attributes, corporate policy attributes, and then ultimately we have this automation layer or policy layer on the outside, which makes all of this happen. So that we can go through a policy and say all things that were written by Ben over 90 days should now be put on the cheapest storage we have. I didn't define what storage system that is, because each time we roll in something that's cheaper, it'll just migrate automatically to something that's cheaper. Right? That's what the policy said. We didn't say migrate it to, disks in the box or something like that. We just said the cheapest storage. This is what object storage is all about. So you can see, number one, that we still protect the data. We have policies around that. Right? It's pretty efficient because now we're not looking for every single file in everybody's home directories and hoping that they might have saved it onto the corporate drives in order to do something about it. We could even do data duplication at that point if we wanted to. We can add security attributes that say if it was written by the CEO or the CFO, don't touch it, or only the auditors can read it, whatever those attributes are. We can start to archive this onto different layers of economic or cost factors. And the most important thing is we can take any of those attributes and search on it. That's what object storage is all about. Now, I mentioned earlier that there is a correlation between this and big data. If you think about what big data is all about today, it's the analysis of data. You're discovering, you're searching data that you have or actually have access to. You want to use attributes that are related to that data you have access to and do something about it. Create new contexts. Understand the context in which it was created. So object storage, the underlying, if you like, the data layer for big data is object storage. What HDFS, as one example, is doing is object storage. What all your document management systems have been doing is a specialized form of object storage. All those PAC systems is specialized forms of object storage. So this is not new, right? We want to look at an X-ray and say it's a broken arm. That's just like saying this is letter.docx, right? We want to know whose broken arm it is. We want to identify whether it's the right to you or the left, right? We want to know the circumstances in which that arm was broken. We want to know the person to which it was attached or not attached, depending on why we're doing the X-ray. All right? We've got to have reasons for the data to persist. And that's why object storage becomes important as we move forward in all forms of computing. I also use the word reuse. For a long time, computing has been a linear event. You have a computer that captures transactions, and you put it on some storage that moves that data to some sort of reporting or analysis computer that does its work and puts it somewhere else. So it's fairly linear. The reason why this is drawn as a sphere is that I can now deploy any form of application against any data at any time, so long as I have the right security attributes and it's actually relevant to what I'm doing, or the search attributes. So for the first time, we are making the world data-centric, which is the world we live in today, right? Now, apart from the fact that this gives us more information, it also gives us that ability to reuse data in many different ways. So where I started was this concept of storing data because you have to, I don't want to do it. All of a sudden, that data that you had to store can have new purpose in life. That purpose could be to generate new competitive advantage, create some innovation, profitability, something that is more than just cost efficiency. And that's why object storage becomes important. As object storage becomes important, we do have some challenges, and this is what I want to help ask from the panel and maybe even the audience to help me with these things. We defined object storage 6 or 7 years ago. That's several lifetimes, obviously, in the technology arena. And at the time, we had 4 attributes for object storage. It had to have user-definable extensible metadata. What that means is I can put my own metadata or descriptors around the data object, and I can do more than one of those descriptors. I think that is still an applicable test for object storage. Location independence was important back then because we had all these disparate storage systems and we had to somehow link the whole thing together. Now we have an added surprise of the cloud. We don't need to actually know where this data object is stored so long as there's some relevance or some relationship to that piece of data. And the important thing about object storage is we're not confined by the directory tree. Not everything starts from root, directory, subdirectory, etc., etc. Any collection of data that meets the set of attributes you're looking for, that search, can become a view into that set of data. So imagine this. We have the finance department. We have 5 people in the finance department. They're all doing their own spreadsheets. And we want to know what they've been up to. In the old days, you'd have to go to 5 separate directories and go and look at all of those files. Now I can just look at Excel files created by finance department. And that's the view I have. Because frankly, I don't care who created it. I just want to know that they exist, and I want to know what's there. Right? And that's where object storage comes into play, and that's why the test of location independence becomes important, right? Because I don't care whether it's in the cloud, next door, on my laptop, or wherever it is, I just want to know that it exists. The self-referencing one actually is the one that I struggled with in 2013, 2014. The whole idea of self-referencing was the idea that it doesn't have to, it could persist on its own. I think that's more of an academic idea. So when I say self-referencing, the file or the object itself would actually have a label tattooed on itself, so that if you went looking for it in this object ether, and you say, hey, object 456, it would just suddenly jump out and say, hi, I'm here. Interesting concept from an academic perspective. I think that is one of the tests that we can probably strike out today. And then the last thing is that dynamic presentation, which I talked about before, where instead of going down a very defined or predefined and prescriptive directory tree, now we can look at the data in all sorts of different ways. So to make it simple, I think what we can do is probably strike out the last 2 bullet points and just keep the top 2 in sort of figuring out what is or isn't object storage. So I'm going to ask the panel, for those of you that have actually stayed awake for all of this, and those of you that aren't nodding because you're falling asleep, has anything changed in the last 6 years? Do we care about this stuff any more than we did 6 years ago? I think the answer to that is yes, sorta. All right. We care about it because of cloud. We don't care about it because of the technology in and to itself. Right? All of a sudden, when we have to deal with S3, when we have to deal with Glacier and OpenStack, etc., we suddenly have these attributes magically available to us and that we have to deal with. All right. If you move your application into S3, you can't just do a DD or a copy command or anything like that. You have to reformat that data and ingest, what we call ingest, sounds gruesome, metadata into it so that there's something more than just a file name, right? And there are appliances and software out there that helps you to ingest metadata into those files. So this is obviously an entree and a very, very deliberate attempt to link objects in cloud, right? Hence, because it's the session, number one. But number two, as we look at object storage, what we didn't realize that many years ago was the influence of cloud in terms of object storage. And that has raised a number of interesting questions for us. Number one, is scale out a key criterion in object storage? Now, many people, actually, who thinks scale out is actually important? I actually didn't care about your answer. I just want to make sure you're awake. Interesting responses. About a third of you thought it was important. I actually want to argue the opposite. I don't think scale out is actually part of a definition of object storage per se. It happens that scale out makes life easier, right? But if you wanted to, you could put everything on the scale up system and manage one system. It just simply means that you have a single point of failure. That's something between you and your officers and not my fault, okay? So scale out, I think, is an interesting element that helps us to reduce costs as well as provide redundancy and performance. But I'm not sure, and I'm not trying to pick fights with you guys, although I'm happy to do that outside about this question. Scale out in and to itself is not a necessary element. The second one, and this is the most contentious question out there, is NAS also object storage? Hands up for those who say yes. Yes, yes, yes. I'm going to say no on that one. No user-definable metadata.
Sure there is. Yeah. We've had file systems for 20 years now that have extensive flash reuse reach right into
traditional NAS based around NFS, but specifically 3.0 and CIF. Sorry, I probably should have been a lot more specific about that. Yes, NAS systems based on ZFS and variations on the Google file system does have that. I will give you that. Traditional NAS, as in what we think about NetApp and other traditional NAS providers, you can put third-party user extensible metadata against that. I just don't buy it. And this was a very interesting question internally when we wrote this paper, whether NAS is or isn't. We believe two things. Number one, metadata is not the be-all and end-all of that test. Remember, going back to our test earlier, it's location independence. NAS, traditional NAS, did not have location independence. It was very much forced down a directory tree. Right? You started the root node, a root directory, and then things spanned it out. Yes, scalable NAS does change that with global namespacing, etc. Not taking that away, but traditional NAS itself, we didn't believe, and I certainly don't believe, falls under the object storage test. So, what about the extensibility and user definability of metadata? I think we kind of answered that along the way already, that becomes an absolute key criterion to what is object storage. And the other contentious issue is, where do you keep the metadata? Some people want to keep the metadata all in one server. Parallel NFS 4.1 is one example of an approach like that. Some people want to keep the metadata across multiple servers. It's really what's your pleasure. I personally, and this is a personal view, I like the distributed metadata concept only because it does give you that redundancy and it doesn't generate a bottleneck in the metadata server. Now, that being said, the metadata server doesn't do much other than serve up locations anyway, so again, I think it's 6 of one, half dozen of the other. Take your pick, whichever religion you want to go with. biggest problem with object storage today is standardization of metadata, all right? Even within a single industry, they don't have standardized metadata across the board. There is attempts to move towards that, and certainly cloud storage providers like S3 does help because now you're conforming to somebody else's singular standards. But if you think about the variations in the health and life sciences vertical, right? Just because I call this an elbow, somebody might call it whatever the Latin name is for this joint, right? So we haven't got yet some standardization that is global, distributed, accepted, and there's nothing that you or I can do in this industry or in this room today other than force the industry groups to get to their own standardization. Now, we know what happens with that, right? As soon as you standardize something, somebody's going to change it. So this is a battle that we'll never win, but at least we can get to some basic level of standardization. We can do data interchange a little bit better. The other argument against standardization, by the way, is proprietary value. If I don't tell you how my data is formatted, then you can't find it and you can't use it, so no. Okay, where that fails is in the big data environment where we are exchanging data, where every company in the world has suddenly become a data as a service provider because they can sell off their CRM information to somebody else or to research groups, etc. So maybe this sort of momentum might have some change along the way, and I've already gone over time. So the last thing, and this is where we go into the cloud discussion, is object storage essentially back-end storage, or is it really an addressing system? So I've argued that object storage isn't object-based storage, OBS, but actually OAS, object addressable storage, where this is essentially a software layer that sits on top of storage that's underneath from any vendor or a single vendor, however you want. And that leads into the question, and I'm going to hand it over to Evan at this point, of software-defined storage and cloud storage, because where does object addressable storage, cloud storage, and software-defined storage all merge? Are those synonymous with each other? Are they different? So maybe that's what we can have a conversation about, and I'll let Evan take over. Thank you.
Thanks, Ben. That was. So, do you believe in object storage?
Absolutely. Yeah.
No. That was a great job.
Was that not clear? I'm sorry.
That was as clear as I've ever heard somebody put the case for objects. So, thank you. That was great. We have a great panel here today, and really our goal is to talk about the fit of open approaches or open storage or software-defined storage in the cloud. So just to quickly differentiate that, as opposed to storage as a service, we're talking about storage as a fundamental infrastructure component for large clouds. Where does it fit? Where are the gaps? What's good? What's bad? What do we need? Nexenta, obviously, is what we need, but anyway. And so what I'd like to do is maybe just quickly go down through the panelists, which is a tremendous panel, who have built, architected some of the larger and more interesting clouds out there, and get them to say a little bit about themselves, and maybe what is the most commonly deployed storage in the environments that they either manage or write software for, as the case may be. So, Boris.
Hello, everyone. Before we move into this, I wanted to maybe disrupt the flow a little bit, and Ben, before we moved off the topic, ask you kind of a question that I've been aching to ask as I was listening to your presentation about object storage. So it seems like the main point you're making is that one of the key values, if not the only main important value of object storage, is this user-definable parameters that allow you to ultimately create different views into the object storage pool and move away from this obsolete directory tree concept. The other interesting thing that I've been thinking about is that as we're moving into kind of an object storage world, object storage becoming more popular, the parallel trend is that also search is becoming much more sophisticated and much more intelligent. And when we're talking about writing any kind of descriptors for an object, such as you were giving, letter from who, what's the importance, etc., and there's a lot of management overhead. It's a big pain in the ass to attach all those descriptors. And given where the search is today, you maybe not need those descriptors. You can just go, if you have a good indexing engine, you can just put in a search line saying, I need this, and it'll give you all the objects, regardless of them having that descriptors attached to them. So is it really that important to have these descriptors, given that the search intelligence is becoming better and better? What are your thoughts on that?
I think it's a question of whether you create those descriptors dynamically or statically. I mean, some people want to do it statically ahead of time because it essentially is it can become a batch process. Again, it's really more of a religious war between whether you want to do it dynamically or not. It's also a conversation between whether it's search or discovery. Again, I don't want to split hairs here, but there are differences. But I think understanding what the data is about in some way ahead of time certainly aids in more comprehensive and more accurate search and discovery. So I guess.
But I think as we dig in, I think we're seeing at least. I'm not the OpenStack expert on the panel, but my sense is that today's cloud environments, cloud stack as well, is starting to provide context to the storage. That context could be not just the metadata. It could be, hey, this is for this app, and some of the stuff happening in heat, et cetera. So which. Also sort of begs the question, what are those descriptors that are important for the storage? Is it the metadata itself, or is it that, hey, no, it goes, this is my volume I boot from, and this is my backup? But this is good. We're into the meat, and nobody even knows who we are, which is so I'm Evan Powell, by the way, founding CEO of Nexenta. Tarkan Manor is now our CEO. He's going to be our keynote speaker here in a minute. Boris, please.
So sorry for disrupting the flow. My name is Boris. I'm a co-founder and chief marketing officer at Mirantis. Mirantis is today the effectively #1 pure play OpenStack vendor. We are definitely #1 in services. I believe we're also #1 in training, and we also released our distribution just about a week ago. We're not #1 there, but just you wait. Naturally, all of my storage-related viewpoints are going to be very OpenStack-centric because I'm not a hardcore storage guy, but I'm a hardcore OpenStack guy. Do you want me to share some storage highlights or pass on the...
Pass it. Why don't you pass? Thanks.
My name's Ken Pepple. I'm Chief Technology Officer for Solinea. Solinea is a software and services company that primarily deals with OpenStack. However, before I founded Solinea, I actually ran development and operations for Internet Network Services Public Cloud for a year or two. And then, obviously, before that, I worked with Sun for a long time, actually as a CTO for their systems line of business.
Hello, and for us in the corner here, I'm Joe Little. I'm a principal systems architect at Stanford University Electrical Engineering Department. I've had the pleasure of being there quite so many years and being at the middle of a lot of, we've been basically the middle of a lot of the key technologies and companies that have come out of the Valley, the Googles, the VMware, and the whatnot of the world. My hand in that's maybe minor, but what's interesting is the trends we see and how we get in front of those. Current one, and where I kind of sit in front of right now, is this whole SDN trend. Many people don't like the whole software-defined asterisks, and including the people behind it. That was actually attributed by other people to the OpenFlow effort, among other things. What's interesting, I run the deployment group for SDN. We are seeing sort of possibly where we think the market needs to go next. And I'll get to this in probably some follow-up questions here. But we actually run private clouds. We heavily use them. We just definitely are waiting to see with bated breath exactly when this stuff will congeal and get around stuff. And we heavily involved ourselves with not just companies that come out of Stanford, but other vendors come in and try to play in our environment to see what works. That's how I got involved with Nexenta early on, and a lot of other vendors right now are coming in for this whole OpenFlow SDN stuff, and they're coming in including from a storage angle, a switch angle, a VM angle, compute angle. So that's.
Thank you.
Sorry. Hi, good morning. My name is Sheng Liang. I'm the CTO for Cloud Platforms Group at Citrix. I came into Citrix through a couple years ago through Citrix's acquisition of a company called Cloud.com. We were one of the early players in making a piece of software called Cloud Stack. It's very similar, has a very similar purpose to OpenStack, and we helped a lot of organizations build infrastructure as a service cloud. And one of the difference, between Cloud Stack and OpenStack is Cloud Stack does not have a embedded software storage component. So we've had the opportunity of partnering with a lot of software storage, especially software storage players like Nexenta. So we have a lot of common users and customers between Cloud Stack and Nexenta.
Thank you. So a bit of a softball question, but maybe I'll spice it up slightly. So in a lot of storage deployments in the cloud these days, you see direct attached. Mm-hmm. And as a storage vendor, effectively, although we're more than that, is storage even relevant? Storage in the way we think about it, storage as shared storage with file, block, even object permissions, or should we be thinking that, in the future, cloud management itself will handle all of that intelligence, and you're just going to have DAS? So, Boris, you look like you want to say something, so hopefully related. But,
I'll try to stay as related as possible. We've seen different storage architectures in building OpenStack clouds, but there's a couple of patterns in general that I guess I can talk about. One pattern revolves around large scale-out clouds, and those are the ones that are being built by service providers or, in some rare instances, large enterprises. And in those situations, the storage backend ultimately is kind of it's an afterthought, because you expose storage services as a kind of higher level of abstraction component. So you assume that you have a lot of tenants and they need different storage flavors. So you provide different versions of block storage you can use for kind of your run-of-the-mill volume block storage that is meant to attach to a VM. You can use something like a bunch of JBODs and Nexenta running on it. If you want some super high-performance storage with QoS, you'll move into kind of an SSD paradigm. If you're exposing, for example, like a database as a service, again, you go with a high-performance backend. But I mean, the bottom line is that when it comes to kind of large scale-out clouds, there is no one trend. It's really, you have to ask the question in the context. So for database as a service, what's kind of the optimal architecture? For the just run-of-the-mill block storage, what's the optimal architecture, etc. Now, this is the first bucket. The second bucket, and actually today, when it comes to OpenStack, given that everything is early, it's probably a more common bucket, and that's the bucket of the guys that just doing, relatively small deployments, they're playing with it, or the use cases specifically dev and test. And in these cases, when it comes to the backend, they want to simplify manageability as much as possible, and they want to optimize for cost. So in that case, I think this is really where kind of a open storage paradigm is very relevant, because in OpenStack specifically, Ceph is very popular. Sorry, but the reason for it is because you can do both object and you can do block with Ceph, and you can just have one system kind of exposing, covering two layers of cloud services, so to speak, and it's simpler to manage, and just people like it for it, and they don't care really about already kind of a finer grain details such as the QoS on volumes or things like that. So
That's good. Yeah, thank you.
Yeah, and so I think, Boris is correct on there are falling into two buckets. I think people that are doing the more advanced use cases, though, are really seeing that they are going to have to create basically services at a higher level there, and it will actually bleed down into that infrastructure, and that infrastructure actually does make a huge difference there. When you're an operator especially, a lot of people, especially a lot of the smaller operators, cloud operators out there, kind of decided we will go ahead and build an object store and people will just come to it. That did not happen unless you're Amazon. And Amazon, the reason why people came to it is they realized that really storage is a platform, especially object storage. It's a platform where you will build solutions on. Hopefully other people will build those solutions for you. The reason why S3 is extremely popular is because Dropbox is on there. Because all these other people have built their solutions on top of that. And so as a vendor, or as an operator at least, you really need to be thinking about how can I make this the best platform for other people or yourself to create solutions on, because it's that higher level service, not the low level service where you're charging 10 cents a gigabit per month, but the higher level services that you're actually going to be able to make some money on. I think you'll see a similar thing bleed over into the enterprise. And even today, we worked with customers who are doing big data. That is a dramatically different cloud, and especially use of object storage and block storage, than you're going to find in people just setting up a converged store because they're playing with things. And I think as you start to see people do these large production big data, you're going to see more and more of that.
I want to say something quick. DAS is inefficient. DAS is costly in tremendous amounts of ways. All right, we live in a world in which data is interchanged. Data is used in different ways for different purposes. While extreme cases like a Facebook or a Google have built and essentially been forced into building something with a shared nothing environment, I cannot see in the long term, especially in the enterprise use.